Hey, welcome back everybody. This is our video solution to problem 7 from Superquiz 3. And we are now going to be finding a Maclaurin series for, whoa, x times e to the negative x cubed over 2. Well, we want to use what we know, all right? And what we know is that the exponential function has Maclaurin series. Okay, well, we're going to have a sum, and we're going to have 1 over n factorial x to the n starts at 0. All right, so this is the Maclaurin series for e to the x. So forget about this x at the beginning here for a moment. Let's just worry about this piece. If I wanted a Maclaurin series for e to the negative x cubed over 2, I just have to replace my x by negative x cubed over 2. So e to the negative x cubed over 2 will be the series starting at 0, 1 over n factorial x, and then up here in the exponent, we're going to, well, let's do it this way. We have negative x cubed over 2 to the nth power. And it's probably good if we rewrite this a little bit. So I have 1 over n factorial, but now look, I have an alternator, right? So I have a negative to the n, so that's going to give me an alternator. I'll shove this up in the top. But I also have this 2 in the denominator, and that's raised to the n. So I also am going to multiply down here by 2 to the n. And then I have x cubed to the n, which I can rewrite as x to the 3n power. Okay, so that's a little bit of work, but that's not the worst thing in the world. But remember, we did have this x, so we're going to need to include that finally. So x e to the negative x cubed over 2 will be x times this series. And I can just move the x inside, and that'll increase the exponent here by 1. So I end up with the series starting at 0. I have an alternator over n factorial 2 to the n times x to the 3n plus 1. Now, just as a little bit of trivia here, if I take this piece in the denominator, n factorial times 2 to the n, so n factorial times 2 to the n, this looks like n times n minus 1 times n minus 2 times dot 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 times 3 times 2 times 1. That's the n factorial. And then I'm going to have times 2 times 2 times 2, and I have n of those. And what I could do is just rearrange this, right? Put each of these 2's with a number in this sequence going from 1 to n. And I'd end up with 2n times 2n minus 2 times 2n minus 4 times dot 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 times 6 times 4 times 2, right? I'm just doubling each entry in here. And this is exactly 2n double factorial. So if we wanted to put this all together, we could write this as 2n double factorial. Totally not necessary. I might even prefer it broken up this way for other purposes, but again, it's a nice little bit of trivia for you. All right, we will see you next time.